Okay, we are going to go ahead and get started. So thank you all for joining us here today for a joint webinar between Scytec and CGTech concerning the integration between DataXchange machine monitoring and CGTech VERICUT, the standard and digital twin simulation verification. And the topic of this morning's webinar is going to be CNC machine connectivity, the integration between the aforementioned two software platforms I just mentioned, and what that holds for the future of manufacturing and digital twins. So for those of you that are new here at Scytec, we have a monthly webinar concerning something related to machine monitoring, smart factory technology, etc. Normally about data exchange related topics, but this morning, we actually have a very special guest with us from CGTech, a Mr. Jeff Fagley, who is their VERICUT product specialist. He is going to be doing some demonstrations about the three different modules inside of the CNC machine connectivity integration, which include Precheck, CNC machine monitoring, as well as Postcheck. Now, for those of you that are new, we also have a little heads-up display that you could put any questions that you may have regarding this integration, and we will be answering those at the very end of this webinar. So I'd like to go over the order of events of this webinar, and first what we are going to discuss is why is shop floor connectivity important? And then what is CNC machine connectivity, followed by some demonstrations of the three individual modules inside of this integration. Those will be done by Mr. Jeff Fagley, after which he will then hand the microphone back over to me, and I will discuss the current support for this integration, as well as what the implementation looks like, followed by some use cases, and then how to find out more. We hope that you guys reach out to us for some personalized demonstrations of this. And if you're going to be going to IMTS, you're in luck, because both Scytec and CGTech are going to be right next to each other in the East Building, level 3. And finally, to round out the webinar, we will have a section for any questions that you guys may or may not have. And as I said, if you have those, feel free to type those into the little Zoho heads-up display, and we will be answering those at the end of the webinar. So first, I'd like to discuss why is shop floor connectivity important. And the high value of this partnership between CGTech and Scytec can be summed up as, through CNC machine connectivity, end users can benefit from having VERICUT access real-time machine data from Scytec's DataXchange machine monitoring platform for the most accurate digital twin possible and prevent any unforeseen errors from occurring. Now, even with VERICUT, you're going to be left with some questions that can still need to be answered, such as, the simulation ran without issue, but then when you got to the shop floor, some problems had arisen. And let's say you weren't even in the shop floor at all, and when the NC program had run, did anything negative happen? As well as other questions like, is my CNC machine running as fast as it can? Is it running at full capacity, 100%? And how much longer until the part is finished machining? Some other questions include, were tools in the machine set to the correct lengths? Were any e-stops or negative unplanned events, did they take place while you were machining? Were feed rates or spindle speeds modified? And was the correct NC program or subroutine applied? Now, managers, NC programmers, and owners themselves are going to be asking different questions as well than what was just previously stated. And that could be, was the machine set up correctly to even run the job in the first place? And if ran on a different chip, did anything negative happen? So specific to what we are discussing here today, why is it so important to be connected to your CNCs out on your shop floor? And that can be summed up by saying that being connected bridges the gap from a CNC machine simulation that happens in an NC programming department to then what actually happens out on the shop floor, providing a holistic, real-time, and historic approach to digital twins. So let's go ahead and get into the meat of this webinar and start discussing what is CNC machine connectivity. And before we kind of really get into that, it's beneficial to have an idea of the foundation of this integration. And CNC machine connectivity allows VERICUT to access Scytec DataXchange real-time machine data and shop floor analytics to take your shop floor to the next level. So if you're not aware, DataXchange is a machine monitoring platform. And if you look over there on the right, you can see some of our real-time machine monitoring dashboards that can tell you what's going on with your equipment out on your shop floor in real time. You're looking at the equipment view on there at the top with the 4 different colors, as well as our RTV real-time viewer right below that. And to kind of sum this up really easily, you can look at that image over there on the left. So DataXchange is taking information that is getting pulled off of your machines, and then it is then giving that information to VERICUT. It's probably the easiest way to sum up about how this integration works. So from here, I'm going to pass the torch over to Mr. Jeff Fagley, who is going to kind of just run over what VERICUT is and then talk about each of the individual modules and then show a demonstration. So Jeff, whenever you are ready.
Thanks, Jeff. So as Jeff had mentioned here, in case anyone's not familiar with VERICUT, we're the industry standard when it comes to CNC machine simulation and C program verification and optimization. So our software, VERICUT, does a variety of things from, detecting collisions and errors on your NC program and subroutines before you get down to the shop floor, finds out any errors of inefficiency, and it also has capability to further optimize your program as well. And VERICUT also has capability to do, as we mentioned, CNC machining, additive, as well as composite programming and simulation, just to give you an idea of what VERICUT is. You want to go to the next slide, Jeff? So as Jeff had mentioned, CNC machine connectivity is a partnership between Scytec's DataXchange software and our VERICUT. So the way this works is DataXchange is connected to the real CNC machine down on the shop floor, and it's gathering that information, to put up in its various displays and whatnot. And then VERICUT connects to DataXchange for two-way communication. And we'll explain that in a little bit more detail here in a few moments, but there's notifications and everything that go back and forth, as well as data that you can get to use it within VERICUT. But that's in a nutshell how our CNC machine connectivity works. If you want to go to the next slide again.
Yeah, I'm there.
Okay. So CNC machine connectivity consists of a few different modules. There is CNC Machine Connect, which consists of CNC Precheck as well as Precheck within VERICUT. So what CNC Precheck is a standalone application that acts as a go or no-go gauge down by the operator. So you can have this software loaded on as many computers or laptop, Windows type tablets as you want down on your shop floor to use. And then Precheck within VERICUT gives you a little bit more functionality to investigate issues on these 5 key data points that we'll show you here in just a few minutes. And then there's a second half of this, which is CNC machine monitoring. So that consists of 2 parts where it allows you to connect directly to a machine and view how the machine is operating through a live stream within VERICUT. And then the other side of that is what we call Postcheck. So think of Postcheck as an investigative tool that is, as serialized part numbers are being machined down on the shop floor, that data is being recorded of how the machine was behaving, how it was moving, parameters that were set, and whatnot. And then you can go, should there be an issue down the road, you can go grab that data that was archived and replay that to investigate what happened should you have gotten a discrepant part or something like that. So that's the 4 modules that we're going to show you here in just a few moments.
So just tell me when you want me to go ahead and play.
Okay, yeah, go right ahead. So we're going to start off, and I think it's best explained to explain these modules how they fit into a workflow. So we're going to start off down on the shop floor as the operator. He's got the machine set up. We've got the machine set up with a fixture, the stock modeled, all the tooling and the offsets are loaded, as well as the work offsets. The operator is ready to press cycle start, but he pauses for a moment and runs pre-check. And this acts, as I said, as a go or no-go gauge. And what it does is it checks for the parameters, the initial machine location of where it's sitting, the work offsets, the tooling offsets being used, as well as the NC program and any subroutines that might be in this setup as well. And what you'll see here, you'll get an array of lights. So if the operator gets all green lights, this acts as an extra insurance. So that CNC machine is set up and ready to run, just as the VERICUT simulation, as well as the documentation that he got had explained. If there's any red lights that indicate differences in those key data points. Now, in the background, there's also communication going on. This is that notification that I've been talking about that's going on between VERICUT and DataXchange. So here you can see that there's an email that's also passed and sent to the appropriate parties, as well as these messages can be sent, as I said, from email, text, or even a Teams message. And in this case, we can see we've got a couple of red lights, so we need to address that before we move forward and actually machine that part. So if you want to go to the next slide then. Now, in this situation, so we're transitioning over to the NC programmer. So he's also received that notification that there's been an issue where a pre-check was ran and there's some issues to investigate. So within VERICUT, you can run that same check. And you can see here we're looking at the work offsets, the tooling offsets, as well as the NC programs. And the advantage here in VERICUT is now you've got some investigative tools that you can dig into this a little bit more. So you can see, even though the work offsets were green, we can take a look and see them all listed out here along with their values. If we look over at the NC program, now we can see that there's a main program, as well as a variety of subroutines. And in this case, you'll notice the reason that was red is I didn't get the NC programmer didn't get the latest program revision down there. It looks like it's also missing a subroutine there towards the bottom. The other advantage you can do with the comparison functionality here is you can look and see, and in this case, you can notice it looks like the feed rate has been adjusted from the program that's down on the shop floor to what we originally sent down there from VERICUT. So we'll need to address that as well. And you'll also notice that darker light, that just shows that was that subroutine that we didn't send down to the shop yet. Now, if we transition over to the tooling, we've got functionality that compares the tool links to what we had in VERICUT to the real tools that are down on the shop floor. And if we'll notice here, there's a difference in the length of tool 1. So what we can do is we can update that value from the real machine into VERICUT, and then we can go back and replay that simulation. So you'll notice here, if we go back to that tool, once we've updated it, you'll notice that tool shortened a little bit. That cutter was pushed up into the holder just a little. And now what we're going to do is we're going to take that data that we've updated, and we're going to rerun that through a simulation. And I'll fast forward this a little bit just for the sake of time, but we can quickly rerun the simulation using the data that was from the shop floor, from the real machine within VERICUT, to see if we want to use that, or if we do need to make adjustments that something would still not be right. For example, a tool length offset or anything like that. So as we fast forward here, you'll notice there's a variety of errors that popped up down at the bottom. And if we zoom in here using VERICUT's program review, we can notice that shortened tool created a bit of a problem. It looks like we have a little bit of a rub on the part with the holder. So we're not going to be able to use that shorter length. So that's really the functionality that you have within Precheck. You're able to run that operation or run a Precheck down on the shop floor as kind of a go, no go. And then the NC programmer has functionality where he can go in and further investigate and see if there's any issues here within VERICUT and make adjustments as needed. Now, if we want to fast forward just a little bit, now that we've gotten the part running on the machine and we're moving forward with making a series of parts. As we mentioned, one of the next functionalities that we have within VERICUT is CNC machine monitoring. So this is where we can live stream data coming from the real machine on how it's behaving and running, and see and view that within VERICUT. So here I can simply make a connection, and it will pick up all the data points that you can kind of see displayed on our heads up display there. And it'll show the machine with feed rates and the end block number that's being processed. There we go. So you can see the end block number that's being moved around, the work offsets that are being ran along with the tooling information. And it also shows you all the overrides. So you can see that in this case, that override is dialed down a little bit to 90%. And you can see there's a variety of other information you can see within our status window there on the left side with some of those green fields and that. So should the machine happen to go into any kind of alarms or e-stop states, all that information is shown as well that you can see here in real time within that live streaming capability. Now, finally, if we transition a little bit further down in the workflow, now we've been running these parts, a series of these parts, let's say, for example, 20 or 30 over the last couple of days. And yesterday evening, there's been an issue where I received information that we had a discrepant part. What happened? So that's where Postcheck comes into play. So Postcheck, now I can go back into the archive data that we've been recording while DataXchange is running in the background, collecting all that information on how the machines are running on the shop floor. I can go back to a point in time, so let's say yesterday at around 9:30 or so, and find out what happened on that particular part. So I can grab a segment of time and I can replay those exact same data points that you saw within the live streaming, from the NC block to the tool number, the work offsets, feed rate overrides, spindle loads and whatnot. I can replay all of that in VERICUT to see how that part really ran, and then use that to find out what happened. Maybe somebody changed a program, maybe a tool was adjusted as far as putting a replacement in and the length wasn't set properly, thus creating some kind of a problem. So that's the power and advantage of having Postcheck, where we've got that data being archived of every part that's being machined down there. And then we can go back and replay that data and use that for investigative purposes if there's a problem, as well as if I want to use that for any further improvements, for further optimization or further program improvements of any kind like that. So that is CNC machine connectivity in a nutshell.
Okay, well, thank you, Mr. Vagley, for showing us CNC machine connectivity. From here, I would like to discuss what the current support for CNC machine connectivity looks like. And as of right now, we have quite a few different machine control types that are supported, including the FANUC I series, which consists of the 0, 30, 31, 32, and 35i, as well as the Makino Pro 5 and 6. Some DMG control types, as well as the Akuma OSP 300 and 500 series. And on top of that, we have quite a few works in progresses that are either now testing or soon to be testing, including the Siemens 840D, the Siemens Cinemeric 1, some Heidenhain common models, including the 640, the TNC7, or the TNC7, Heidenhain ITNC 530, as well as the Haas next generation controls, and then finally the Mazak Smooth. So what does implementation look like for this? And it's actually a lot easier than you might think it is. So owning or having VERICUT and Scytec DataXchange are kind of must-haves for this, but really any modern machines that support Ethernet capabilities, with those machines having the ability to be either on a wired or wireless network is really all that we require to have. And if you guys have any questions about this kind of stuff, please reach out to us. We will gladly walk through everything, show you a demonstration as well of CNC machine connectivity. Now, from here, I'd like to kind of go over some some use cases for each one of the individual modules that Mr. Vagley just demonstrated for you, as well as kind of reiterating some of the practical uses of it. So starting off with Precheck. Precheck allows manufacturers to verify if their CNC machines are set up the way that they were intended. If a discrepancy is found, the operator can see the Precheck failed and be alerted of the event via email, text, or Microsoft Teams. A dashboard will update notifying the operator to rerun the operation. And after a successful Precheck with the updated values from the CNC, will then save the files for later verification. And a use case for CNC or Precheck would be manufacturers can use it to compare items such as work offsets, tooling offsets, CNC programs, and machine parameters and positions to ensure the CNC is set up the way that it was meant to be before running a part for the first time. And the standalone application as well for Precheck. The standalone application runs on PCs or Windows tablets out by your CNC machines, and it allows personnel to ensure that key aspects of the machine setup match what was verified in VERICUT without checking out a VERICUT license. Next, we will go back to the CNC machine monitoring live streaming feature. And the CNC machine monitoring feature enables real-time streaming and monitoring of your machines directly within VERICUT. And this allows for continuously updating the connected VERICUT session with real-time data, including access positions, cutting tools, active tools, and work offsets, as well as information on the machine's performance and behavior. So some use cases for CNC machine monitoring is this allows manufacturers to view past the machine enclosures, the guards, the flying chips and splashing coolant that you can see during production, to be able to kind of view where that tool is currently at in the production process, as well as seeing what cutting tool is active or what work offset is currently loaded, giving insight that other manufacturers would be operating without. And if you're unable to be physically present by the machine, you can easily get answers to questions about your machine's current status with just the click of a button. Finally, we will discuss some use cases for the Postcheck feature. And to reiterate again, the Postcheck capability is an investigative tool which allows manufacturers to review archived data directly from the NC machine within a VERICUT simulation to observe how a machine ran. Events can be selected and the production can be played back inside VERICUT as if it were running in real time, allowing you to see exactly what took place, ensuring that issues are ironed out for the future. So a good use case for this could be Postcheck can be used at times when a tool or override was changed or the CNC came out of automatic mode, or common stoppages such as M1s happened. And this will allow you to inspect and diagnose any issues that occurred during machining of a specific part. So if you're interested in this, we definitely ask that you reach out to us, but I'm going to go over quite a few different ways that you can do that. So as I mentioned earlier, both Scytec and CGTech are going to be at IMTS this year. The Scytec booth is going to be 13240 in the East Building, level 3, where we will be both doing live demonstrations of CNC machine connectivity as well as the DataXchange machine monitoring platform. You can also go to Scytec.com and click the schedule a demo button right there at the very top of the page. As I mentioned, Scytec will be literally right across the aisle from CGTech at IMTS this year. The CGTech booth is going to be 1330 in East Building, level 3. And you can also go to CGTech.com, request a quote to find out more about CNC machine connectivity that way. Now, so you saw Mr. Vagley kind of go over a demonstration of the 3 modules. Mr. Vagley will also be presenting at IMTS on Thursday, September 12th from 2:15 to 3:10 p.m. in the West Building, on the first floor in room W192C. And he will be doing a presentation titled Closing the Gap Between Simulation and the Shop Floor, and covering some topics concerning how data can be retrieved from a machine tool, to be used proactively and identify and prevent problems from happening, what information can be retrieved and analyzed from the machine pre, during, and post machining, and how this technology improves overall manufacturing flow by saving time with enhanced data. So if you're going to be going to IMTS, yeah, definitely look for both CGTech and Scytec there. Here. And from here, I will go back and see if there are any questions. So the first question that has come in, and maybe Mr. Vagley, you can answer this. What does the timeline look like for the controls on the Siemens and Heidenhain machines?
So I think as Jeff had showed on the supported controls, we're actively working on them. And I believe our plan is to have them done by the end of September, if not a little bit sooner.
Yeah,
so
as I understood it, it was going to be Q4 of this year.
Okay, yeah, that might be. Is that what we had listed there? I know we're changing this almost weekly, so.
Okay.
But yeah, we are actively working on those now, doing testing and stuff with simulators and on some real machines very soon. So.
Well, I guess it was actually a little bit clarified a little bit here better. So early Q4.
Yeah.
So we have another question in here is, do you offer trials for this? And yes, we do actually offer trials for CNC machine connectivity up to about a month. And if you guys are interested in doing that, then yeah, definitely please reach out to us. Okay, we have another question that came in here. Is the data stored in a database forever or for a limited time?
Do you want to take that or do you want me?
I'll let you take that. And also we have our own product specialist here as well, Chris Hamlin. He's going to be answering some questions that I will then verbally tell everybody.
So I guess I'll start and Chris jump in and help me out on this. But I know this is the nice flexibility of connectivity and how you can tailor it to fit your needs. You can set up the database to store data for however long you need. In some cases, customers may only keep it for 30, 60, 90 days. Other customers who have much more longer life cycles on their parts may need it for many years, but that's entirely up to you. That's just being able to store the data either in a cloud application or through GovCloud, or be it on-premise, depending upon your needs and requirements.
Yeah, there is nothing to add to that. Jeff was right on the money. I would also like to add, though, the storage options for this are all ITAR compliant. We have another question that came in. So is the data easily looked through after the fact? And yeah, it's absolutely. It's very easy to pull this data back up.
Yeah, so one thing I can say is right now what you saw in the demonstration was where you can simply go back to a point in time. There, we are continuing to evolve and add more enhancements to the software. So there are some future enhancements that you should be seeing here by the next release of VERICUT to even further enhance that interaction of being able to find data and go back and look at it within VERICUT.
Okay, we have another question that came in here. Do you have a development timeline for Mazak controller Smooth G and Smooth AI?
Chris, do you have any info on that?
So we currently don't have a development timeline for the Mazak controller Smooth G or Smooth AI, but that is a possibility for down the line at some point. Okay, we have another question here. What type of hardware does this require? Does this run on a network server that houses the VERICUT license, or will we need a dedicated PC for this? Jeff, I'll let you answer that.
Sure. So at least from the VERICUT standpoint, if you currently have VERICUT, which I believe I'm going to assume you do from that question. Their CNC machine connectivity will continue to run just like it is on any kind of a computer you have VERICUT loaded and are currently working with. Now, from the data exchange standpoint, that Chris or Jeff, do you want to add to that? As far as the hardware and that goes there, and the same. And let me just throw in as well for the VERICUT licenses, connectivity is just an optional license that you can have, that you can grab and then release, just like many of our other modules that we have.
Yes, you do need a data exchange license to talk to the machines, and it can be installed on the same PC as the VERICUT license. And we do have another question that came in. Is the FANUC 31 Model B Plus controller already supported?
Yeah, I believe that is. We have that's that series of 0i through the 31i. We support all of those FANUC series.
Yes, it is supported by the 31 series. Yes, to answer that question, for the Model B, it is. Well, okay, I will, doesn't look like we've had any more questions come in, so I will give this here another 30 seconds or so for any final questions. For those of you that did show up here today, thank you. You can find this webinar. This should be emailed to you about 10-15 minutes after this is over, and you can find this on our Scytec YouTube page, as well as if you get our newsletter, it should be in that. And this should be online for viewing probably by the end of this afternoon.